Global warming and pollution are common topics in modern society, but carbon emissions are an especially strong concern. Thankfully, great minds around the world are working to cut down on carbon emissions to help both the environment and us. One of the technologies developed thus far is carbon capture and storage, otherwise known as CCS. What is CCS? Well, in short, carbon is captured during industrial processes, then transported and placed underground. But what specifically is happening in this process? Well, let's get into the details. It starts at the location in which carbon is emitted, which would include places like refineries, power plants, steel manufacturing locations, and much more. At these locations, flue gas, which is a byproduct of combustion composed mostly of carbon dioxide, nitrogen, and water vapor, is collected. It is then put through an aqueous amine solution called monoethanolamine, also referred to as MEA. The carbon dioxide and the flue gas then chemically reacts with MEA in the following reaction. This reaction only uses the carbon dioxide components of flue gas, so that when the solution is heated and the reaction reversed, pure carbon dioxide is released and quickly captured. The next step is to get CO2 ready for transport. The CO2 is compressed and heated to about 31 degrees Celsius or more. This causes the CO2 to become supercritical, which is a state of matter that has properties of both a gas and a liquid, which results from compressing the substance while heating past its boiling point. The pressure from compressing it keeps it in an almost liquid-like state, while heating it past its boiling point also gives it properties of that of a gas. Overall, the process creates something dense like a liquid but mobile like a gas. Lastly is to store the CO2. A storage reservoir is located and the CO2 is injected into said reservoir. Here, the CO2 remains indefinitely. Now, how does the CCS process relate to the big ideas of chemistry? Let's start with 1. Scale, proportion, and quantity. As we discussed, CCS selectively takes CO2 from the large amount of flue gas byproduct by using monoethanolamine to react with it. This reaction takes flue gas, a larger scale object, and selectively takes CO2, a smaller object, from it. Structure and properties. The process of CCS hinges on the structure of monoethanolamine, which allows it to selectively bind to CO2. Due to CO2's electronegativity, it's attracted to the lone electron pair on the nitrogen atom in MEA. The reaction of these two species results in an ion that is pretty stable. Other elements cannot react with MEA to make this stable structure. 3. Transformation. In CCS, CO2 is transformed in multiple ways through the process. First, it undergoes a chemical change when it reacts with MEA, and then again when the reaction is reversed. Then, it's compressed and heated into its supercritical state, which is a physical change. All of these changes are essential to the process of CCS, which would be non-functional without them. Carbon capture and storage is a great example of modern technology's use of chemistry to capture and store CO2 before it can reach the atmosphere. It ties back to the big ideas of chemistry, while showing how science can make a great impact on climate change and greenhouse gases while we work toward clean energy solutions. Thank you.